This is 11th chemistry. The topic is hydrogen. Hydrogen was invented by Henry Cavendish in 1766, and the name hydrogen was proposed by Lavoisier. Why hydrogen? Because it is made up of two words, hydro and gene. Hydro means water and gene means producing. Therefore, its meaning is water producing. Why water producing? Because when burned in oxygen, it produces water. Okay. This is hydrogen is the first element of the periodic table. Its atomic number is 1 and its mass number is 1. That means it has one proton and one electron. Okay. Then it has two isotopes: deuterium, which has one proton, one electron and one neutron. Okay. Then we have tritium, which has one proton, one electron and two neutrons. So its mass number is, here we have mass number 1 for hydrogen, deuterium has mass number 2 and tritium has mass number 3, while their atomic number is 1. Okay. So how it naturally it exists as a diatomic molecule, we write it H2. Therefore it is also called a dihydrogen, which means that it is a molecule of two atoms of hydrogen. Its position in periodic table, its position in periodic table is anomalous. Anomalous means it is disputed. It resembles alkali metals, which is one of the periodic table, group 1, and it also resembles halogens, which is group 17. Okay. But it has been placed in group 1 with alkali metals, which include lithium, sodium, potassium, rubidium and cesium. Okay. Let us first see it is how it resembles alkali metals. How it resembles alkali, resemblance with alkali metals. Resemblance with alkali metals. First is electronic configuration. Electronic configuration. You see the electronic configuration of hydrogen. Its atomic number is 1. You can see sodium, whose atomic number is 11. It is 1s2, 2s2, 2p, no, 1s2. Then we have lithium here, hydrogen, lithium, Z3. Okay, it is 1s2, 2s1. Okay. Similarly, we have then sodium, Z is equal to 4. Configuration is 1s2, 2s2, 2p6, 3s1. So you can see that it is here, it is 1s1, it is 2s1, it is 3s1. Then we have 4s1 in case of potassium. In rubidium it is 5s1, and in cesium it is 6s1. So this has a single, these alkali metals have a single electron in the lost shell of their lost shell, subshell S, subshell S of the lost shell. Okay. So the electronic configuration of hydrogen resembles these alkali metals. Then we have second, electropositive character. Electropositive character. What is electropositive character? We see that sodium, for example, loses one electron to form sodium positive. Similarly, we have this potassium, which loses one electron to form K positive. Okay. In the same way, hydrogen loses one electron to form H positive. So it has an electropositive character like alkali metals. So it has been placed in this group first of the periodic table. Then we have oxidation state and valency. Valency and oxidation state. We see in its compounds, sodium has +1 oxidation state. This is NaCl, this is positive and this is negative. This is single positive and single negative. Similarly, we have potassium chloride, it is single positive and single negative. In the same way, we have HCl, this is positive and this is negative. So it is valency and oxidation state of +1 resembles those of alkali metals. So this is another resemblance of these hydrogen with alkali metals, that is group first. Then we have combination with electronegative elements. Fourth is combination with electronegative elements. electronegative elements. Halides, for example, we have potash, we have halide, we have these electronegative. We have halides have with these electronegative. Hydrogen reacts with these to form HCl. Sodium reacts with form NaCl. Potassium form. So like these alkali metals, it also reacts with electronegative elements like halogens, and we have sulfides. Sulfides are also electronegative. We have H2S, we have Na2S, we have K2S. So like these alkali metals which react with these electronegative elements to form compounds. Hydrogen reacts on the exactly on the similar lines to form different compounds with electronegative elements. Then fifth resemblance with fifth resemblance is liberation at cathode. Liberation at cathode. Here in this case, we see that if we pass electricity through HCl, we get hydrogen at cathode and chlorine at anode. This is at cathode and fluorine at anode. Okay. And in the same way as NaCl, this gives twice Na at cathode and chlorine at anode. Similar is the case of potassium, cesium, rubidium. They also are liberated at cathode, and these are liberated at cathode. Hydrogen is also liberated at cathode. So this is a resemblance of this with these alkali metals. In next video, we will discuss how it resembles these halogens. Okay.